Let's continue looking at definite integration. Let us integrate x, the function x, with respect to x from, say, 0 to 1. What would that give us? So remember, we define the boundaries of this integral. So we're actually finding the definite integral of x. So when you integrate x, you get x squared divided by 2. Alright? You have your square brackets. On the right square brackets, you put your lower and your upper boundary. Next, you substitute the upper boundary for x. So you have 1 squared divided by 2 minus. Then you substitute the lower boundary for x. So you have 0 for x, 0 squared divided by 2. So what you have now? 1 squared is just 1 over 2 minus 0 squared is 0 over 2 is 0. So the answer is a half. Now, let us look at the graph of x and then consider the boundary from x equals 0 to x equals 1. We want to open our graph plotter. Alright? Because we want to see the fact that we actually are finding an area. So our graph is ready. We have y equals x. That is our line x, but let me make the line thicker than it is so we can see it easier. And let's zoom in. Now, this is our graph, and we have the lines. This is the line on our graph, y equals x. And remember, we're integrating from 0 to 1. Let's maximize our graph. We integrate from 0 to 1. So what that really means is this. We are integrating from 0 to 1 of x dx. Means that we are looking at an area bounded by the line x equals 0. In this case, you wouldn't really have a line because it crosses the x-axis at 0. And x equals 1 right here. It's also bounded by the x-axis. Alright? And bounded by the curve or the line here, x. Let's draw the line x equals 1 going up. Nice. So what we're really finding is this area that I'm shading here, and we're going to use another method to see if we can get that same area there. Alright, nice. Here, if you have this triangle, it is 1 wide and 1 high. Because you have 1 here, and the area is half times the base, which is 1, times the height, which is 1. Half of 1 is half, times 1 is half. Alright, so we do have half, which corresponds with what we looked at. The integral is a half. Now, let us erase all of this. And this time, we want to integrate from, let's say, from 1 to 2 of x dx. Let's do that. This is x squared over 2, and the boundaries are 1 and 2. So in this case, we substitute 2 for x, is 2 squared over 2, minus substitute 1 for x, which is 1 squared over 2. So what we get now is 2 squared is 4 divided by 2, minus 1 squared is 1 divided by 2. 4 divided by 2 is 2, minus half. 2 minus a half is 1 and a half. Alright, now in the interest of trying to find enough space, let me just write the answer down here. 1 and a half. Let me rewrite that. It's kind of messy. The answer is 1 and a half. Alright. Now, let us look at the graph itself. Make note of the working if you need to. Now let me erase the workings so that the board is not crowded too much. Now what I'm doing is looking at that section of the graph. Here we have the line x equals 1, because there's 1 here. The line x equals 2, it's right here. If I can draw it straight down and try to make it as straight as I can. You have the x-axis and y equals x, the line y equals x, which is there already. So the area that we really are calculating is this area, right? Let me shade it. So this shaded area is what we're really calculating. Now, remember this was 2. Now suppose we use another method to calculate the area. Would we still get back 1.5? Let's see. Let's divide this shape into a rectangle and a triangle. The rectangle is 1 wide, from 1 to 2 is 1, times it is 1 high. You can see it from the graph here, times 1, which is 1. Okay, good. The triangle is 1 wide, and from 1 to 2 it is 1 high. The area of the triangle is half the base, which is 1, times the height, which is 1. Half of 1 times 1 is half. So if we add the area of the rectangle, 1, plus the area of the triangle, half, we get 1.5. That's exactly what we got here. When we use integration, we got 1.5. Alright? Now, suppose we do this now. Let's make an adjustment. This, alright, this is -1. And here is +1. Let's play around with that. We are integrating from -1 to +1 of f of x dx. What would we get? Here, when you integrate x, you get x squared divided by 2. The boundaries, you put your x squared divided by 2 in square bracket, you put the lower boundary here and the upper boundary at the top. Equals. You substitute the upper boundary for x, we have x squared becomes 1 squared over 2 minus, then the lower boundary, negative 1 squared, put that over 2. What do you get? 1 squared divided by 2 is half, minus negative 1 squared is positive 1, and positive 1 divided by 2 is half. Now what is half minus half? It's 0. That's interesting. Let's look at the situation we have here in front of us. This is saying the area we want to find is bounded by x equal negative 1. Is negative 1 here. X equals positive 1. The upper boundary, this is 1. The x-axis and the curve y equals x. Alright, well, it's a straight line, but I still call it a curve. This is the part of the x-axis. So the area that we really found was this. And then this. But hold on, that doesn't look like 0. This area is not 0, so why did you get 0 here? Any ideas? Why would you get a 0? Interesting. Alright. You can see it. The integration process considers this area as negative and this area as positive, and it added them. Now when you have a negative number plus the same number but it's positive, you get 0. For example, negative 5 plus 5 is 0. If you just add them like that, so you get a 0. Now, what this is saying is that you should, anytime you have an area where part of it is above and part of it below the x-axis, and you're using integration to find the area, you should find them separately, and then you will have positive numbers for both of them. If one is negative, change it to positive, because it's an area and it's not really realistic to use a negative value for an area. And then you add the areas. So suppose instead of this we do this. Let's integrate from 0 to 1 instead of from negative 1 to 1. From 0 to 1. So we're going to have to erase this negative 1 and put 0. So we're going from 0 to 1 of x dx. We have x squared over 2 from 0 to 1. So what you have now is the upper boundary 1 squared over 2 minus the lower boundary 0 squared over 2. So it's half minus 0 divided by 2, which is 0. Half minus 0 is not 0, it is a half. So in this case, it is half. Alright, so what it's saying is that the area here is half square unit, and the area here is half square unit. Now, if we want the total area, we say half plus half, which is equal to 1 unit squared. Alright, so there you have that. So you have to be careful when you're doing calculation in terms of using integration to find an area. If part of the area is below the x-axis and the other part is above, the negative and positive will cancel each other if you just Run your integration from the lowest boundary to the highest boundary. All right, so we'll continue looking at definite integration in the next video, so I will see you.